It's Haystack Live. As ever, we have a fantastic speaker for you, and there'll be a chance to ask some questions at the end of the session. Just a couple of announcements. We've got our natural language search training coming up at Open Source Connections late in November. So do check that out if you can. And there will be more Haystack Live presentations as well. We'll talk more about that at the end. We're recording today's session and it'll be up on our YouTube channel. So do check that out. And of course, encourage any colleagues or friends to join the group and come and enjoy our presentations. So if you have a question for Tim today, do drop it into the Zoom chat and we'll come to those at the end of Tim's talk. Otherwise, I'm going to hand you over to Tim Allison, who is always an engaging and interesting speaker. And Tim is going to talk about something that I've encountered back in my career, which is duplicate and near duplicate detection. And he's going to tell us how to do it at scale. So over to you, Tim.
Thank you very much, Charlie, and welcome everyone. Let me get this up and running, and away we go. Yeah, so thank you, Charlie. Thank you, Open Source Connections, for hosting this awesome series. I encourage everybody to check out James Rubenstein's talk from the last Haystack Live. It was really a nice overview of relevance assessment. Also, of course, Berlin Buzzwords has done a save the dates, so make sure to check in and save those dates because that's another exciting conference series. All right, so today I'll be talking about duplicate and near duplicate detection at scale. A little bit about me. I do recognize a number of folks who are here, so welcome, old friends. But at this point, I'm a data scientist at NASA's Jet Propulsion Laboratory. I'm also the chair and VP of Apache Tika and a committer on some other Apache projects, file processing, PDFBox POI, Lucene, Solr, and OpenNLP. And I'm a member of the Apache Software Foundation. Yes, so today's talk I'll go kind of an overview of what I see as various ways of looking at a search system when one comes across one that's in production and people are saying, yeah, this isn't working out as well as we would like. So I'll talk about some of the areas that I've looked into search systems before, just to give an overview. Sorry, Charlie, I cannot help but give a plug for text extraction and assessment. This will not be a Tika talk, but I will be mentioning that just briefly. Then I'll do the case study of duplicates and near duplicates. And it's more of this talk just for expectation setting. I do not have easy buttons. I have not implemented new algorithms. This is more of a lessons from the field in looking at one particular search system at JPL. And then of course I'll end with a conclusion. All right. So off I go. So search system assessment, a 20,000-foot overview. There are many, many ways of assessing how well a search system is working. We're all probably familiar with offline, where you have ground truth queries and you have expected documents, and you run something in Chorus against those to make sure to measure how well you're doing and experiment with improvements. There's online user behavior, and again, see the last talk, which was really good for that, and click-throughs, how long people are dwell time, conversions, all of those other fun things. User feedback has been extraordinarily useful for some of the work that I've done, because we're not, on the systems that I'm working on, we're not selling stuff. And for government intranet sites, trying to figure out what's going on and what people are thinking about, what the specific issues are that can be fixed. Often user feedback is a useful thing. I've also found the fourth leg of the stool is a technical review of the system, and also the data, and I'll go into those in a little bit more detail. The point of this slide is to situate this longer, or the duplicate document detection in a larger context of how one can measure and improve a search system. So Charlie, this might look familiar to you. If I gave you a quarter every time I used this, this is a really nice overview of the various components of a search system. Obviously you got to get the data in, got to extract the text, then you have content conditioning, throw it into the index, and then at search time, you can do all sorts of things to the user queries and to the results that come back before showing those results to a user. So within a system assessment, some of the things that I've looked at have been the crawler configuration. So, how much logging do you have? When do you know when something's gone wrong? How quickly do you know when something's gone wrong? How often are you revisiting sites? Those kinds of things. Within text extraction, obviously, especially if you're not dealing with just HTML, want to know, what's your parser coverage for your given file types. What are your stack traces that are most problematic on your document set? Those kinds of things. Schema and field configuration is critical. In a number of settings, I've found that really basic changes to the analyzer chain can fundamentally change and improve search pretty dramatically. Sometimes people use just the defaults, or sometimes they want to use something that's just cool and new, and found that thinking carefully about the user queries, about the data, and designing and engineering those schemas can be important. Also, of course, query parser configuration, Boolean operator, how you want to weight different fields, how you want to combine the weights of different fields into the relevance ranking can be really important. Within a data assessment, I found that just simply doing what file types do you have, what's the quality of text extraction, and I'll talk about that, and I'll be in my little plug for that shortly. What's the quality of the metadata? A simple histogram on dates can be awfully revealing. One place where I did an evaluation of a search system, I did a histogram of dates by month, and there was this massive spike this one month, where they had thousands and thousands of documents. It turns out that was when they migrated their old system and they didn't keep any of the dates for their old system. So all of those documents had the date of when they were migrated into the new system, which admittedly is one way of doing it. But for confidence in a system, that can be a little bit challenging. There are no cheap fixes to that, but it was good to at least see that and show that to the search team so that they recognized what was going on when people were sorting by date. Liveness of documents and URLs. How well is the search system capturing updates, deletions, modifications, insertions to the underlying document store, and then of course duplicates and near duplicates. So what I'm doing is just trying to situate this one little talk in a larger framework of things that one can do in looking at a search system to try to find areas for improvements. All right, so now the plug for text extraction assessment. So within Tika, we have this Tika eval module, which is a command line tool, but we're also making it available coming soon to, via Tika server, at least for some of these statistics, so that you can index these statistics and use them at search time or as part of a post hoc analysis of how well you're doing, and open up tickets in Tika when you find areas for improvements. So one of the key statistics within Tika eval is something we call the out of vocabulary statistic. And what we've done is for about 120 languages, we've taken the top 30,000 words as computed from the Leipzig corpus. And when text comes in, we run language ID on it and then say how many of the words that were pulled out of this document had a common word in it from these top 30,000 per language. And on the same file, you can see for Tika 114, it was lang ID was Chinese. With Tika 115, same file was German. The out of vocabulary on the Chinese is 100%, whereas once we made the improvement to Tika, we get German and 54% out of vocabulary. So this is a programmatic way of seeing when you're probably doing a better job of content extraction. There are lots of edge cases and reasons why this isn't a perfect metric, but it can be extremely illuminating. This is an example of running it on an internal JPL document set. This document had a language ID of Nepali, out of vocabulary of 99%. The content, you can see there's some hosed up stuff at the beginning of the document. Not sure why that happened, but running this on their document set allows us to point to documents that require deeper dives. And typically, what we can do is get the coarse-grained, high-level statistics on a collection, and then do random sampling on those to figure out what the main causes of some of those areas for improvement can be in text extraction. But basically, if you're not doing this kind of thing, you don't know what you can't find, and you can have serious problems in your collection. All right, the next thing you can do is at index time, perhaps run these statistics and say, oh, this looks like a good PDF. but the text that's stored in the file is complete junk. When we run OCR on that, we get much better text. So you can use this out of vocabulary statistic at index time to say whether you want to trust the content that's stored within a PDF or whether you need to run OCR at that. And in Tika, what we're trying to do is push the processing and the application of Tika eval stats further into the parser to make choices during parsing time about what to do, but we're not there yet. All right, done, Charlie, done with Tika for now. All right, so now off to duplicates and near duplicates. All right, so this talk is a deep dive into a look I did into a particular index, internal index, intranet index at JPL. There were about 12.5 million documents. I looked at the dev index. I did not want to mess with production. I did some comparisons with production, and it was determined that it was close enough, slightly out of date, but close enough. I didn't want, this covers their internal intranet, so it's not binary document heavy, as I'll show with a list of file types. It's mostly HTML. I wanted to avoid major computation on the production cluster, and this document set was small enough that I could re-index it on my laptop fairly straightforwardly. So it's not quite at scale, but it's not a small amount of documents, and some of them are quite large. The other key thing was that this was a very low lift effort. I wasn't given a lot of leeway to, code out new stuff, use contrib modules, or do anything else hand coded. So I mostly did that, and so that was one of the limitations on this, was simply resources. So use what's available and see what we can do. All right, for this slide, I wasn't able to show you the duplication slides that I have on internal data because it is sensitive to JPL. It's not available for public release, but this is an example of what duplicates can look like. And if you have pages and pages of duplicate files, that can really decrease user confidence in the system. How big of a problem are duplicates? I found it amusing. There's a really good talk at Elasticon Global just a week ago, I think, by Alexei Kovarin on their crawler. The first thing he mentioned was content deduplication for intranets. It was important enough for him that that was the first problem he observed that they had to fix or solve or find ways to get around for indexing intranet and also site content. Google also has numerous patents for this. I'm not saying they have 51, but if you do search for their Google patents, there are 51 results. And again, they're not all from near duplicate detection, but they do have some important patents around identifying duplicate documents. And of course, Google would prefer that you not engage in duplicate content from an SEO perspective, and they have recommendations on how to handle those, have this notion of a canonical page. So you can have duplicates, but please anchor a rel canonical so that we know which page of the duplicate to serve up in the result set. So duplicates are a major problem, and within the system I was evaluating, people already knew duplicates were a problem, but they didn't have any tools to evaluate what the level of duplication was. So just to give some background on the system that I was working on, this web index system, there were roughly 9 million HTML files, a bunch of image files, a couple 100,000 PDFs, and then a bunch of other file formats, so largely HTML and image files. So what I did, which was very easy to do computationally, was calculate literal digests on the bytes of the files. Fortunately, that had already been done, so I relied at index time, so I relied on those digests. But then the next thing I did was calculate the unique SHA-256 on the text that was extracted from the document. And I normalized the document. I ran it through a Lucene, I think, standard analyzer to get rid of the content that would not be indexed, but kept everything in order, and then took a SHA-256 on that. And then the next thing I did was steal from Nutch, and they have what's called a text profile digest. We'll talk about that in the next slide. What that does is you tokenize the content, the text, and then you sort by, and you quantize the number of times each term appears in that page. And then you sort by descending order of frequency of term, and then alphabetically, so that you get, so the two pages that are very similar would have exactly the same text profile in air quotes, and then you take the hash of that. The default Nutch text profile drops words that show up once or fewer times, or on the low end of the quantized scale. I experimented with leaving all the terms in. So there were three pretty much low-hanging fruit things that I looked at initially: digests, text digest, and text profile digest, and those all yield either MD5s or SHA-256. All right, so this is an example of a page that has a different digest, a different text digest, but the same text profile. And it's pretty much exactly the same content, except that the query in the search system has been ordered differently. So you can see that the the actual query or the navigation stuff within the data is ordered slightly differently. So you're still getting the same content, give or take, but the text digest is different, and obviously you're going to have a different underlying raw binary digest as well. All right, so within this index of HTML, largely HTML files, within there were 9.2 non-image documents. There were 8.6 distinct digests, 5.2 distinct text digests. And then when I did the keep all words for text profile, that dropped down to 5.1 million. And then when I removed infrequent words, which is the default Nutch text profile, we got down to 2.7 million distinct text profiles. So you can see some dramatic drops in the number of distinct files when you start doing these three different levels, or in this case, 4 different levels of digesting of the raw bytes, just the text normalized, and then the text profile. So I dug into that a little bit. This is looking at the the most common digest per different type of digest. So the raw digest, the text digest, and the text profile. I was just stunned that we had 2.8 million of one text digest. You can see that clearly there was some major difference in the markup or in something else in those pages, because the most frequent raw digest was only 27,000. But even still, going down there with the text profile, you still have roughly 500,000 as the second most common text profile digest, and so on. So it looks from this that there's a whole bunch of duplication. So I dug a little bit more. I found that there was one page, the crawler had been hitting an error page 2.8 million times on the dev server. So they had 2.8 million documents that just said error page. The web server encountered an unknown runtime error, cannot display the page. And because that HTML page included the URL that the crawler had hit, the literal digest was different, but the text digest was exactly the same. And of course, the text profile was exactly the same. Now, this page wasn't indexed that much quite as often in production, but there were still roughly 880,000 copies of this page in their production web server. So that's a major problem that they couldn't see before when they were only doing the raw digests. All right, so my initial takeaway was, whoa, there's some easy fixes, but let me go a little bit further into into the discovery phase of what I found. So what I really wanted to do, those three techniques are dirt simple. They are not rocket science. What I really wanted to do was something a little more fun, near duplicates with minhash. An intern had implemented something like this before at JPL. They hadn't actually run it on a production or even a dev system, but it had been implemented. The devs knew about it. I wanted to try it out. There's a filter in Elasticsearch for minhash, so it's pretty straightforward to run. So you index a field with a minhash analyzer, digesting 5 grams. I'll show what those are shortly, and then run a more like this to get documents that are similar to that based on the hashes. Now, I know that there are more efficient algorithms for finding similar things with minhash, but that wasn't built into Elastic. There is an add-on, and I have a link to that at the end, but it wasn't something that I felt comfortable within the confines of this particular task using. So I literally just ran a more like this query. 5 gram, of course, is just take a string, divide it into every chunk of 5 words. So this worked really, really well on a toy set of synthetic documents, like 1,000 documents. What I did was take each document and then, just checking the time, sorry, and then perturb it a little bit. And I wanted to see if I would retrieve it based on how much I had perturbed the original document for how sensitive minhash was on returning that document. And I was really happy with the results. If you did a more like this query with a pretty high threshold, it really did bring back the documents that had only been twiddled a little bit. But what I found when I tried to run that on the full 9 million documents or whatever was that it would have taken roughly a year of single-threaded query time to pull back the documents at the the index time for adding this extra min hash field was not noticeable or negligible, but the search time would have been prohibitive. I found that when I manually coded using, just take the term vector for a target document, take the term vectors, and then submit my own term query, that it sped up quite a bit, but it still wasn't orders of magnitude faster, and it was still just not acceptable for what I wanted. So there are ways of improving min hash. I may have been doing something stupid. There are better algorithms for finding min hash similarity that are not more like this and are not hand coding effectively more like this. But we had so many other fish to fry in this index that I said, we'll hold off on that until later. One thing that I was really curious about, though, was why min hash was so slow. And this, as part of the discovery phase, led to some rather interesting finding. So the notion is with min hash that if you're indexing 5 grams, those should be pretty rare. What I found was that in this index, the 5 grams were not at all rare, and there were a lot of very common 5 grams. And the way I found this was I re-indexed the documents with a 5-gram standard analyzer and in Solr. And then I just wrote a little thing to hit the Solr, I think, terms API and take the 10,000 most common 5 grams that showed up in the index. Unfortunately, this functionality, as far as I can tell, is not available in Elastic. You can't iterate through all of the terms in an Elastic index, which is why I indexed it with Solr. The code to do this, there's a link for that towards the end of the talk, but that's available in a tool that's on GitHub, and I'll show you a link to that. So I then with these 5 terms, I took the 10,000 most common, descending order of frequency. Not surprisingly, an unknown runtime error cannot showed up in 2.6 million files. You would not be surprised to learn that at this point. But then there was a sharp tail and things dropped off. But just looking at these top 10,000, I saw that there were different causes for these. Some were, actual full document duplicate detection. Some were duplicate files. Some were near duplicates. But then there was a lot of boilerplate, whether that was web page navigation or whether that was legal branding stuff. For example, California Institute of Technology government sponsorship was a major one because that shows up in everybody's slide. And there were also some machine generated sensor data that had very similar language in there. So we got a lot of 5 grams from those. So one thing that I was looking at was in trying to figure out actual duplication, near duplication, in looking at this boilerplate stuff. So these are examples of what I was just talking about. So in web page and navigational, science technology launch vehicle showed up in 1.4 million files, and I'll do a deep dive on that shortly. Content announcements, events, opportunities, people showed up in 500,000 pages that were from this one particular site. And then, as I mentioned, there were also these legal boilerplate kinds of things. So this is an example from navigational boilerplate stuff that's showing up on web pages. So the term science technology launch vehicle spacecraft, which are navigational links on this page, showed up in 1.4 million files because they're not removing boilerplate at this point. Just if we pause for a check on relevance testing and relevance engineering, if science, technology, launch vehicle, and spacecraft show up in 1.4 of your 8 million text documents, you can imagine that those are not very important terms. And we do know that those do show up in some of the more important queries. So this boilerplate content, this navigational content, is completely hosing the system for those search terms and taking out the importance of it. So from a relevance standpoint, for queries that included those terms, the inverse document frequency is quite low, and that's just an area for improvement. All right, so just for kicks, I ran Boilerpipe. There's a handler for that built into Tika. There's also a Python library that will do this, and it guesses which are the navigational parts of HTML, and we'll pull that out. On this particular page and on this particular data source, it worked really well. So when I ran that, I got out just the content from the page. We do know Google is removing boilerplate. So when I searched for site marsnasa.gov, you can't find this page, or you can't find the series of pages. Excuse me, but when I search for actual content within that page on the bottom right, it does bring back that document. So this is evidence that Google is running some kind of boilerplate stripping on their public crawler. Yeah, and this is an example of a machine-generated logs. Downlink monitor block has completed, showed up in 14,000 documents, and so on. So that's just an example of the machine-generated logs. So my takeaway was we have plenty of work to do. We shouldn't bother with minhash for now. As part of this discovery phase of why was more like this on minhash performing so poorly, I discovered this 5-gram issue, and the boilerplate is a major problem. We identified some of the machine-generated documents, and this legal stuff is, we should probably come up with a way of extracting some of that or doing something with it. So some of the things I also noticed in just looking through the documents, some of the causes for duplication, we had exact duplicates. Sometimes we had the same document but on different URLs. Sometimes we had images or pretty much wrapper text around images where there was very little text around those. For near duplicates, sometimes we had PDFs and HTMLs of roughly the same content. There were versioning issues, so we had different versions of the same documents. Again, near duplicates, documents with very little text. I didn't see this very often, but you can find in some search systems asymmetric duplicates where you have, for example, the initial email, and then if somebody forwards that and puts their own stuff, that initial email is within the second email, but it's smaller than the second email. So those were some of the categories I noticed. So removal is difficult to come up with an automatic algorithm for removing it because sometimes duplicate documents differ in key features. So you can have a PDF with the same text content, but different images or even HTML. Sometimes users allege they need to find all versions of a version document, and sometimes a small difference in the text is important. So for example, in this slide, this is just wrapper around an image, and just checking the time again, around the image. From, we every day on Mars, we take a bunch of photos, make them publicly available, and you can see the only difference here is the time from this given camera for when something was taken. So you wouldn't want to necessarily hide those, but you'd want to handle them carefully given the objectives of the website and how people are searching. All right, so step 1 recommendations for the system: experiment with the boilerpipe handler versus the top 10,000 n-grams, and find pages based on that list of common n-grams. We know which pages have a lot of boilerpipe or boilerplate, so you can run boilerpipe against those, make sure it's removing them, but then you also want to make sure that you're not removing desired text. And again, because we have those common 5 grams, we can use that in an evaluation. So recommendation is consider looking and definitely do an analysis, see if that will help, because that would dramatically improve the uniqueness of the pages and the content within those pages. I recommended also indexing the token count, the language ID, the digest, which they were already doing, the text digest, and also probably the text profile digest with the documents so that you can do an analysis of those and potentially do group bys or other things. And I'll talk about some of the options for handling those in the next slide. Obviously, for major sources of malignant duplicates, for that one web server not available page, put that on your skip list at the crawling stage. Stop indexing those and delete those from the index, please. Now, the next question is, what do you do with these duplicates or these near duplicates once you've identified them? And the answer will depend on the search system and user expectations and the data. So one thing one could do is say, if you have an exact duplicate, don't insert it. That's kind of a hardcore way of approaching it, but certainly reasonable in some settings. However, it's also possible that you can do a group by based on the duplicate text digest or the duplicate digest, depending on the results. Going back to Google's notion of that canonical version of a page, insert a process that identifies the canonical version of the page. I'm pretty sure Nutch does this based on recency of the file, the length of the URL, something like that, but somehow have an algorithm that will identify the canonical copy, have that as the main one, and then do a group by and have something like allow users to click on that to get the duplicates or near duplicates. Certainly one could demote duplicates in the relevance ranking, or just have a single button that allows the user to flip on for show me the duplicates or don't show me the duplicates, something like that. So those are some options that I offered to this team. No matter what, though, they will need to have in place something to identify these duplicates. All right. So some of the tools I used in this evaluation, I added some things to it as part of this observation, as part of this evaluation. One is I added the top-in tokens, which works for Solr only, where you say, here's a field, give me the top 10,000 tokens for that field, and it will give you a descending order of those tokens. Much like the Luke toolbox. I also added some features into Tika eval. So I added digest, or digest was already part of it, but I added text digest and not just text profile digest, so that you can index those at index time if you're using Tika eval to enrich the metadata about the content that you're pulling out of files. Language identification was already built into Tika eval, and out of vocabulary was also built into Tika eval already. All right, so in conclusion, sadly, it depends. There's no easy button, but we did discover quite a few things that are actionable and that the search team can work on improving, and also identify metrics to make sure that they don't have any backsliding in these areas for duplicates, for boilerplate extraction, and for some of the other items that I observed. All right, I've included some references. Some of these are the major papers on the duplicate, near duplicates at web scale from Google. And then some other stuff I found that was kind of useful and fun on K-nearest neighbor and LSH for Elasticsearch, minhash and Lucene, and SSDeep with Elastic. All right, so that I've gone through content. If you would like me to go through it again, so we have duplicate content, joking, Charlie. I will stop now and open it up for questions. I guess before I do that, was I on mute? All right, are there any questions? Is anybody left?
Thank you, Tim. So yes, thank you for that. That was great. Just to go through the chat, Audrey asked, what was the data set you got the top 30K most popular tokens from?
Sure.
At the beginning of your talk. Maybe
sure,
just
that was
back to slides. We'll tell you that was that one.
Yep. So that was the, out of vocabulary, the corpus is called the Leipzig corpus. And it is, yeah. The Leipzig corpus is available through OpenNLP's big data repo. And if you Google Leipzig corpus, you'll get links to the individual zip files per language. But OpenNLP has done some munging on that data to make it available so that you can get 120 languages of 1 sentence per row, I think, text files. And that was extremely useful for this. I had initially used Wikipedia dumps in our first version of this, and I think I captured like 60 plus languages with that. But Tika eval is now using the Leipzig corpus for the common tokens.
Hope that answers your question there, Audrey. Eric, I think it is, Ribeiro, said I added a book reference for us for the a book on from the Stanford website there, which apparently has some introduction to the similar items problem.
Yep.
Somebody, Kui asks, could you show again which tool you're using for the boilerplate extraction?
Sure. Yes, let me go to that. I think. Come on, slides, don't fail me now. There we go. Yeah, so there's a demo of Python library, I think, at boilerpipe-web-appspot.com. And then within Tika, there's a boilerpipe handler that will do this kind of thing for you.
Hopefully, Tim, you'll be able to upload your slides to the meetup group so people can get links directly.
Yeah, exactly.
I will add that there are, of course, multiple ways to extract the plain text from HTML. Beautiful soup is also an option people use a lot. And for search, it's generally a good idea to throw away as much boilerplate as you can.
Yes.
Yako, you've got a question? Because we're oh, hang on. Sorry, I've messed up Cedric. Cedric asks, did you use a framework like Norcanex for the web crawling, or was it DIY?
Oh, no, we were not using Norcanex. We were using Scrapy. Scrapy is the industrial grade crawler that is currently being used internally.
I would second the recommendation of Scrapy. I know some of the people behind it. It's a very cool thing. They also have a a website called Scraping Hub and various services, but worth checking out if you want to do some extraction from web pages in bulk. They have some very cool things there. Yako asks, if a document is found in various places, there might be one specific source that is leading, so the original source. That would be interesting to establish and show to the user. Any thoughts on that? What's the chief duplicate, we might call it?
Yeah, and I mentioned a little bit about my understanding of Nutch and what they do for algorithmically identifying the canonical form or the canonical page. And some things they put into their algorithm are recency. The shorter the URL, the better. And I think there was something else. It could be the case, though, that we as there is mercifully at JPL, and fortunately, a really good data curation team. And they do a bunch of manual edits to improve search results. So that might be something that they could look at for a given data stream, especially if you have duplicate or roughly duplicate data streams. Is there one that should be the canonical one for that? But aside from length of URL and recency, I'm sure there are other algorithm things one might use.
Yako, does that answer your question? Feel free to unmute and chip in.
Yeah, thanks. It's a complicated topic, I think, an interesting one though, but thanks.
Obviously, in-links would be another one. I mean, PageRank effectively, right? But within an intranet, as we all know, the links aren't nearly as rich as on the web.
Okay. David asks, he missed the intent of the out-of-language token statistics. Was it just a clue to go looking for junk and then take other action?
There are two uses for that. Yes, that's exactly right. Yeah, so you can find junk. I don't have my slide here handy. It's useful for me as a parser developer and for Tika and other parsers to run this before we do a major release to see if there are any regressions. For search people, though, I would recommend running it to do exactly that, to find the problematic files so that you can either run OCR on it or open up a ticket in Tika or do something with it to identify where those problems are. Typically, so there are a number of sources number of symptoms that something might go wrong, including funny languages. So if you have a mostly English index and you're getting a language ID of Catalan, something probably went wrong. But typically what I've found to be useful is using random sampling the high out of vocabulary documents to get a sense of the spread of causes for those and the distribution of causes. Typically in an index of that big, you're not going to be able to look at each individual one, but random sampling on the high OOV ones can help you identify the scale of the problem and then identify the causes of those problems and hopefully fix those problems.
Does that answer your question, David?
Yeah, thanks. Thanks, Tim.
Fantastic. Do we have any other questions for Tim? Do unmute yourself and chip in.
Hey, hi, this is Abhay, and thanks. This is a really kind of I will say, a great presentation. I have a question regarding, like, you are using you're using scraping internally, or do you use Nutch for crawling the database? And do you have what do you think is a kind of a better from the crawling perspective, and why? I see Nutch has all the features that you mentioned.
Yes, you may have heard that Nutch has all the features I want. The current setup is using Scrapey. I have not done a feature comparison between the two. I do know that Nutch has a bunch of things built in, and there is, once something is up and running, it takes a fair amount of effort to rework that, especially something that's not as fun or as exciting as some other technologies. So we're using Scrapey for now. It seems to work okay, especially once we start implementing these other features, which seem to be part of Nutch.
Okay.
I know that.
How's that for not answering the question?
Nutch does have, Nutch was built by the same guy who created Lucene. So there's some kind of more tight integration possibilities there, but that doesn't mean necessarily it's a better crawler. And as I say, the Scrapey team are also really clever. So your mileage may vary on that one.
Yep. Yeah, I encourage, if you have the resources, to try out both. If you have the resources, or if one's not working, definitely look into the other.
Okay. Any other questions for Tim?
I have a curiosity as to how boilerplate is detected. Like, I understand how you went about it by looking for 5 grams, and as a human, you can look at it and say, oh, there's boilerplate there. But can you surmise a guess as to how those tools you pointed at, like how they fundamentally work? It sounds like a hard problem.
It is a hard problem. There have been a couple of academic competitions in it along the lines of Trek. They were much smaller. I think it was called Clean Eval back in the, I won't give you a year and don't Google it because it will show you how old I am. But it is a hard problem. And I think they're using heuristics like, extent of text between div tags or p tags or something like that. And if they're fairly short, that would be my guess, but I haven't looked under the hood at what they're doing. I will say at another search system where I helped out, they had basically 5 different sources, so they could hand code boilerplate stuff for each source. So they weren't relying on the heuristics built into Boilerpipe to do that extraction. So your mileage will vary, and I certainly would not recommend throwing in Boilerpipe without doing an evaluation to make sure that it's not accidentally hosing up your or removing data that it shouldn't be removing.
Just to add on this, like the web to text is something which is kind of some research around using deep learning to get the boilerplate removal, and there are like papers on that. We had some kind of the interns working on that to have a POC for it, and
very cool.
It works for like most of the, if you have a lot of advertisement and all those stuff coming in. Yep. We really
and that was yes, and yes, I'm sure that deep learning has solved the problem, and that's definitely the way of the future. One really nice thing about doing that analysis of the most common 5 grams was that you had pretty much automatically identified where your problems are and what kinds of things you would want to remove. I do know that I'm pretty sure it's the significant text. Mark Harwood pointed to me in Elasticsearch has a feature, a significant text has a feature where it tries to figure out what the duplicate text is across the subset of documents and removes that in an online way to identify, effectively finding, I'm not sure exactly what the underlying algorithm is, but it's something similar where you identify the common 5 grams in a small batch of documents and don't index those or don't include those in your counts. But I'm sure that deep learning will definitely help with that, because that is a hard problem.
Thanks. Cedric asks, what do you do with the near duplicates? In his case, customers get scared when they see that 500 documents are near duplicates. They have no clue where to start, and they revert back to basic full duplicates.
Yeah, so it depends, right? Some people will not want to throw out or will not want to prevent documents from insertion, and this goes for duplicates and near duplicates. So there are softer ways of handling it that aren't as destructive per se to the original data. As I mentioned, grouping by is one option, and this can be a duplicate by the near duplicate by the either the text digest or the text profile digest. Or show those duplicates further down the search results, or have this global include duplicates button that a user can use. The other thing one can do is go back to the data owners and point out these duplicates and say, do you really want both of these available? Especially if there are large classes of duplication, that becomes straightforward. And the great thing about looking at those 5 grams, you can pretty easily see if you do crosswalk those common 5 grams with URL with the URLs, you can see which domains have the biggest offenders for that duplicate content. So that was a really handy way of looking at who the sources are and potentially, I don't know, talking to humans. Not something I want to do, but getting up and talking to humans to figure out if they can improve that. The other thing I will point out, though, is that I wouldn't want to take duplicate digests or near duplicate digests as indicative for very short, if you only got a little bit of text out, because obviously the That could be one of those little things around an image, or it could be, text extraction failed on that document, you got no text out of it. So you do have to come up with some kind of heuristic to deal with those very short documents, because you wouldn't want to hide all those. They could be distinct information. So no easy answer, I'm sorry.
I'll add another use case for this, which may be informative. So I've worked with news search systems, and in the news world, of course, when they publish a story early in the morning, there'll then be subsequent editions of that story as they can find out more news about it, or they want to add extra information or even take information away, or it's republished in different publications or syndicated or whatever. So very often you end up in a news corpus, you can have a lot of duplication of the same story, and being able to collapse that down into a single story and perhaps show different versions of it, even different versions being published by the same source through a period is quite interesting. So, and usually in that case, you want to use the group by option. You want to create some kind of collapse key to effectively group those together and then show perhaps how that story's changed over the time. So this is a real problem. And especially out in the news, when you take it out to the bigger media monitoring world, you've got a lot of duplication and republishing and even just blatant copying going on. Stories. So this is a big problem.
Thank you.
Any further questions for Tim?
One question regarding the duplicates. Even if like we found the duplicates, how do are there kind of any approaches to see what one to remove? Like if we have two documents which are duplicates, which one to keep?
Yeah, so that goes back to the earlier question about, exactly. How do you identify that canonical one? And that's going to depend on the use case. So in Charlie's case, time, I would imagine, date, timestamp would be quite important, because you want to at least have as the canonical version, the most recent version. Data source would also be an important feature of that. You might want to select a more reliable data source for that, the news source. But within an intranet, things get messy, because you just have stuff, and sometimes the dates aren't reliable, and so going to Nutch's heuristics of short URL, most recent, if your dates are meaningful, and that kind of thing are the only thing that I can think of, short of human data curators determining which source is more reliable or should be boosted as the canonical version for that file. But what I haven't gone into is there's a lot of complexity in figuring out that canonical version in a live crawler, because you may have to switch your choice for that canonical file if when new information comes in. So if your crawler finds the one copy of a file that's way down in your page tree on your website, and then you identify that one as the canonical one, and then later the crawler comes in with one that's right on the main page, then you're gonna have to flip that tag. And from an efficiency standpoint, you might want to do, you probably are not going to be wanting to modify those documents, especially if Lucene is your backend, just from a reindexing or updating issue with Lucene. So that is something that I've kind of waved my hands at, but is a real issue for how to identify canonical, the canonical copy at one time, but then also how to keep that updated over time, as Charlie was mentioning with the news updates, or even with an intranet or site crawl.
What about specifications? What about, what is the most accurate specification for building something? Is it the latest version, or is it the version the senior engineer signed off on?
Right. I push that all to it. Fortunately, at JPL, we have the data curator, so I will let them decide.
Yeah, and you're lucky to have them, because not every organization has that.
Yes, they are an amazing asset, and just having the notion that they recognize the need for that was fantastic, and it's a wonderful team.
So we got a question from Stuart. Stuart asks, what's the rationale for dropping low frequency terms for the text profile hashing? What impact does any low tier term frequency threshold have? Couldn't a number of low frequency terms actually mean it's a near different doc?
Yes, absolutely. And that was one of the problems, one of the concerns I had with text profile, which is why I built out a non-standard version of text profile that didn't drop the less frequent ones. I think the notion behind the less frequent ones is, if accidentally somewhere in the content of an HTML page, the original query that got you there is encoded in there, then that kind of thing isn't something you wouldn't want. That's a low frequency term. But exactly as you point out, as we all know, the inverse document frequency of low frequency terms is important in search. So why wouldn't you want to keep that? So that's why I have allowed both in the Tika eval version of the text profile, because depending on your use case, it could be critical. Those less frequent terms can be critical. One thing one could do, though, is do a study where you do text profile dropping the most frequent ones, and then do the more costly comparison of those ones that match with the most common terms. What were the actual differences? And within your corpus, see if you can afford to get rid of those less common ones, or if it really is wrecking things for you. Again, it depends on your data. It depends on what your use cases are and what your user expectations are. But I agree with you that I also had the intuition that, but the less frequent words are important. Why would you drop them? But yeah, I agree.
Fantastic. Okay, do we have a last question for Tim? I think that's everything for this week. Thank you so much, Tim Allison, as ever. Interesting, useful, and partly about Tika. Thank you so much. So just a couple of closing remarks. I'll just share my screen if I can turn Tim off. If everyone can see that, we've got, obviously we've got relevant Slack. I encourage you to join that if you haven't already. The videos for this talk and for lots of other useful search and relevance talks are up on our YouTube channel. Do join the meetup if you haven't already. I guess you probably all have if you're here, but do pass that on to colleagues and check out the events we're speaking at during the autumn, including Search Solutions and Enterprise Search DC, where myself and Eric are both speaking. Our next talk is on November the 12th. We may squeeze one in before that if we can find a willing speaker. Again, if you would like to talk about search or relevance, do let us know via the meetup group or contact us directly. There's also a call for papers, a call for speakers on the haystackconf.com website. But our next talk that's scheduled is from Nate Day at Open Source Connections, and he's been talking about our entry into the Trek competition this year, which is all about news recommendation systems. And there's some cool stuff there to get around. So do come to that one. And we do also have our natural language search training coming up at the end of November. So please tell your friends. Thanks again to Tim, and thanks everyone for coming. We'll see you at the next time at Haystack Live.